According to physicists, the universe had its origin in the Big Bang, an event that occurred around 13.7 billion years ago. However, the issue that arises is, what caused the explosion, and why? Over time, as we've investigated and learned about the history and science of the Big Bang, it has become the most common explanation for the origin of the universe. Everything we've seen so far has resulted from a great deal of research. Thousands of studies have been carried out by scientists. Additionally, the data gathered has consistently supported the theory of the Big Bang as the primary explanation for the creation of the universe. According to this theory, dark energy, an additional type of energy more abundant than the energy within galaxies, is responsible for the continued expansion of the universe. It acts as a force that counteracts gravity. Since the universe began with the Big Bang, today's science has changed drastically, with new theories constantly emerging as technology advances. We frequently discover that things we once believed to be absolute truths are, in fact, not. One such disruption to our understanding comes from the James Webb Telescope, which has discovered 750 brand new galaxies, none of which were anticipated. This forces us to reevaluate our perspective and learn more about how the James Webb Telescope is altering our comprehension of the entire universe. Join us on this amazing journey that reaches far beyond the observable universe, as we uncover new information about the immense number of newly discovered galaxies. For those interested in staying updated with the latest discoveries in cosmology and astronomy, please support our channel by liking this video and turning on notifications. The images of these brand new galaxies captured by the James Webb Telescope are simply stunning. We can see hundreds of galaxies in a single image, each showcasing its own beauty. These photos are incredibly powerful and should not be ignored. However, what astonishes the general public contrasts sharply with the reactions of researchers. While the images are breathtaking, they do not align with the existing theories. Scientists had anticipated seeing something entirely different. There are more galaxies visible than expected, and these galaxies differ from predictions. They are smaller and appear to be much older than anticipated. These surprises are causing some anxiety among scientists. One article even includes the word panic in its title, demonstrating the seriousness of the situation. These galaxies are not what existing theories predicted. For a very long time, researchers have relied on the Big Bang theory to explain the vast beginnings of the universe. This theory states that the universe began approximately 13.7 billion years ago due to an unidentified cosmic event. Now, however, that definitive narrative is being challenged. The dazzling images captured by the James Webb Telescope have raised serious questions about our understanding of the universe's origins. In particular, these images appear to contradict the Big Bang hypothesis, long considered unquestionable by most cosmologists. The galaxies in these photographs appear too small, too smooth, too old, and far too numerous compared to what the Big Bang model predicts. Some of them are 2 to 3 times smaller than those observed by the Hubble Space Telescope, defying the standard behavior expected in an expanding universe. According to the hypothesis, as space and time expand, distant objects should appear larger, not smaller. Additionally, the James Webb Telescope has observed galaxies that completely defy description. They do not fit expected patterns, and their simplicity is entirely unexpected. According to the Big Bang theory, galaxies at that stage of development should exhibit significant anomalies and variations. Structures are caused by their formation's dynamics and evolution, but the pictures show extraordinarily smooth galaxies, devoid of the level of roughness and complexity one would typically anticipate seeing in galaxies of their age. This defies the expected formation sequence over time and the development of galaxies within the Big Bang theory's framework. At the beginning of all matter in the universe, energy and the elements that make up the universe were condensed into a remarkable singularity, which refers to a concentrated point. The density reached at this point was infinitely high due to the extreme compression of energy and matter. The idea of a singularity is rooted in our current understanding of the laws of physics, particularly the equations Albert Einstein proposed in general relativity. Einstein was a part of the theoretical foundation of the singularity, in which all the universe's energy and matter existed in an extremely constrained form. This high density suggests that an enormous amount of energy and mass was condensed into an infinitesimally small space under extreme densities and pressures, conditions like those found in the earliest moments of the universe. The heat of the singularity is unimaginable. The temperature would have exceeded any temperature observable or reproducible with our current scientific knowledge. Everything was kept in this hot, dense point, the seed from which everything in the universe came. The singularity marked the beginning of the universe, the beginning of everything. After the singularity, the universe began its expansion journey, a process known as inflation. This process took place over more than roughly 13.7 billion years, giving rise to the universe as it exists today. The beginning of the universe's expansion was extraordinarily rapid, due to cosmic inflation. In this phase, the universe grew at a rate much faster than the speed of light. It's as though the very fabric of space stretched, pulling everything within it. Cosmic inflation played a major role in the formation of the universe's large-scale structure. It smoothed out irregularities in the distribution of energy and matter, preparing the way for the formation of stars, galaxies, and other structures. Over time, the rate of expansion slowed down. It is important to note that, despite the rapid expansion during the universe's initial period, the expansion rate can be measured today. The term cosmic expansion refers to this ongoing process. Scientists have observed its effects through a variety of observations, such as the redshift of distant galaxies. These redshifts indicate that light waves expand as the universe expands, shifting wavelengths closer to the red end of the spectrum. Everything that makes up our universe was once condensed into an extremely compact volume. It is astonishing that matter could survive in such a small space. As the universe cooled and expanded, particles like electrons, protons, and neutrons began to interact with surrounding energy and light. These interactions played a significant role in the formation of matter during the early minutes after the initial explosion, a process known as nucleosynthesis. Chaotic and unordered galaxies, often formed through multiple collisions, were expected. But the story as told by JWST, James Webb Space Telescope, is different. The images do not show chaotic galaxies at all. Instead, we see spiral and well-organized disk structures, like those observed in the modern universe. This unexpected observation casts doubt on the notion that galaxy mergers were a common part of early evolution. The idea that these new galaxies experienced numerous mergers, or any at all, becomes increasingly unlikely. The fact that small galaxies would expand and transform into systems hundreds of times larger than anticipated also seems doubtful. This suggests that these galaxies may never have been small to begin with. In addition, the optical illusion expected from cosmic expansion, where objects should appear smaller the farther away they are, fails to hold in this case. Consequently, what we believed so far might be incorrect. Furthermore, the age and number of galaxies discovered by the James Webb Space Telescope also challenged the validity of the Big Bang theory. JWST uses filters to capture images in the infrared region of the spectrum, making it easier to study the colors of faraway galaxies. Astronomers can analyze these colors to estimate the ages of galaxies and stars. I hope you enjoyed this video. If not, don't forget to share it with your friends to help increase subscribers and reach more people. Subscribe to the channel so you don't miss our next video. These revelations from the James Webb Space Telescope have left scientists both thrilled and puzzled. For decades, the Big Bang theory has served as the dominant explanation for the origin and evolution of the universe. It successfully explained the cosmic microwave background radiation, the abundance of light elements, and the observed expansion of space. But now, the pristine, structured galaxies observed at great distances, and therefore at very early times in the universe, are forcing a re-examination of long-held assumptions. How could such massive, well-formed galaxies exist only a few 100 million years after the Big Bang? According to conventional models, this simply shouldn't be possible. Galaxies were expected to evolve slowly, starting from small clumps of matter, gradually growing through mergers and accretion. But what we see through JWST's infrared eyes are galaxies that seem mature, orderly, and massive, far too early. This opens the door to several possibilities. Perhaps our understanding of galaxy formation is incomplete. Maybe the initial conditions of the universe were different than we thought. Or possibly, the physics we currently rely on doesn't fully apply to the earliest moments of cosmic history. Some scientists are even proposing modifications to the Big Bang model, or entirely new frameworks that could explain these observations without requiring such rapid early development. Alternatives like the bounce theory, which suggests the universe goes through cycles of expansion and contraction, or the idea that time itself may have operated differently in the early universe, are being discussed more seriously. Others argue that dark matter and dark energy might have played an even more significant role in shaping the universe than previously believed. Regardless of which theory proves correct, one thing is clear: the James Webb Space Telescope has changed the game. It's not just a better telescope. It's a cosmic time machine showing us a version of the early universe we never expected to see. Every new image, every spectrum, every data point adds to a growing sense of mystery and excitement. This is science at its most thrilling, not when it confirms what we already believe, but when it forces us to ask new questions and venture beyond the boundaries of current understanding. So stay tuned. The universe, it seems, is far more complex and more beautiful than we ever imagined. If you found this fascinating, make sure to subscribe and hit the notification bell. There are more cosmic discoveries on the horizon, and we'll be here to explore them together.